Question number 4, if the two regular polygons are equivalent, which one would have the smallest perimeter? We have an axiom that says that if two polygons are equivalent, then the one with the largest number of sides would have the smallest perimeter. It would be the octagon. That's the simple answer. The polygon with the largest number of sides would have the smallest perimeter, and the octagon has the smallest perimeter. But let's prove that just for fun. If I say that both of these polygons have an area of 100 centimeters squared, let us find the dimensions of, really we're after the base of the polygon, of the octagon here. I'm just going to look at the central angle, like from here to here to here, which I'm looking at half of that because it's a right angle triangle, and then we can figure out half the base, and then we can figure out the full base, and then we can figure out the perimeter. All right, we're going to do the same thing for the heptagon. What's our central angle? Like, I mean, from here to here, down to here again. So this angle here, 360 divided by 8, which is 45 degrees. This angle here is going to be half of 45. It's going to be 22.5 degrees. I'm going to call this the height, and this little tiny line here the base. It's not the base of the octagon, but it's the base of this right angle triangle. If we were going to use our trig ratios, this is our angle. The B, the base, would be the opposite side, and the H would be the adjacent side. Okay, this would be our hypotenuse. Here's your right angle. It's opposite. The right angle is the hypotenuse. We're after both the opposite and the adjacent. That would be tangent, opposite and adjacent. So the tangent of theta is the opposite over the adjacent, so it's base over height. We could fill in everything that we know, which is only the angle, so tan of 22.5 is base divided by height. If we cross multiplied, we could say that the base is the height times tan of 22.5. We also know that the area of this octagon, let's just say it's 100, and the area, because these are equivalent figures, the area of the heptagon is also 100. The area of this triangle times 2 would be the area of the isosceles triangle, that is 1/8 of the pentagon. The area of this triangle times 2 times 8, or times 16 of these little triangles, is going to be the 100. So 100 is the little base times the height divided by 2 times 16, and then the 2 goes into 16, that gives us 8. If we divide both sides by 8, we end up getting 12.5 is base times height. We have two equations with base and height, and we have two unknowns, so we can solve for base and height. The base is 12.5 divided by the height. Here, I'm going to say that the base is height times tan of 22.5. If both of these are equal to the base, then I can say that h times tan of 22.5 is the same as 12.5 divided by h. And then I'm going to cross multiply the h here. So we get h squared times tan of 22.5 is equal to 12.5. Divide both sides by the tan of 22.5, and that gives us h squared is equal to 12.5 divided by the tan of 22.5. 12.5 divided by 22.5 tangent is equal to 30.177. And that's our h squared. So our h is going to be the square root of that, which is 5.493. H is 5.493, and then we can just feed that back into this equation right here. The base is going to be 12.5 divided by 5.493, which is 12.5 divided by this number gives us 2.275. That's our base. We have 16 of these little things, so 2 of them makes up one side of the octagon, so times 2, then times 8 sides of the octagon, then times 8 sides is 16. We just have to multiply that number by 16, so if we double this, we get 4.55090, and then times 8, or we can multiply that number by 16, same thing. We end up getting 16. 36.407, rounding it to the fourth decimal place, the 8 tells the 1 to become a 2, so 36.4072 centimeters is the perimeter of the octagon. Now we have to do that again for the pentagon. Let's get this central angle, which is going to be 360 divided by the number of sides, divided by 7. 360 divided by 7 gives us 51.4285, and it goes on forever. It's a repeating decimal because we're dividing by 7. We're really after half of that, so divide that by 2. And that gives us 25.714. This is the height that we're after, and this is the little base that we're after. Once again, the tangent of theta is going to be base over height. We know that the area of this pentagon is once again 100. So 100 is equal to base times height divided by 2. So the area of this little triangle times 14, because you have 7 of these isosceles triangles that make up the whole thing. And this is half of the isosceles triangles, so 2 of them make up a side. So 2 times 7, 14 of them. 2 goes into 14 7 times, divide both sides by 7, and that gives us 14.2857 is base times the height. I want to get the base all alone, so I'm going to divide both sides by the height. So we have 14.2857 divided by the height is the base. Okay, and we also have this tangent of theta is base divided by height. And so the base is going to be the tangent of 25.7143 is base divided by height. Cross multiply the height. We have height times the tangent of 25.7143 is the base. Both of these are equal to the base. We're using the comparison method. H times tan of 25.7143 is equal to 14.2857 divided by h. I'm going to cross multiply the h, and so we have h squared times tangent of 25.7143 is equal to 14.2857. Divide the 14.2857 by the tangent of 25.7143 is equal to our h squared divided by, and the tangent of it is 29.6645 is our h squared. Our h is just going to be the square root of that, and that gives us 5.4465 centimeters. So that's the height, and the base is 14.2857 divided by the height, divide that by the height, which was 5.44, and that gives us 2.622 is the base. 14.2857 divided by 5.4465 is the base. We get that from this. That gives us 2.6229 centimeters. So that's half the base. So we could double it and then multiply by 7, or we could just multiply by 14. The big base is 2 times the little base. Doubling this is 5.2458, and then multiplying that by 7 is going to give us 36.72. The perimeter of the octagon is less. It's 36.4072, and this is 36.7206. So even though they have the same area, the octagon has a smaller perimeter, which demonstrates that the polygon with the largest number of sides has the smallest perimeter if we're talking about equivalent figures. And we're talking about regular polygons. And that's it for question number 4. Have a good day.